Hi, very good morning all. This is Radha Krishna Prasad, and today I'm here to take a technical demo for the course that is about to start from next Monday, that is February 2nd, 2026. So as part of this 22 days performance engineering training program, today I'm going to talk about uh, Java performance problems. Okay, when I say Java performance problems, initially we'll start discussing about the common performance issues that we are going to face in our day-to-day activities, in our day-to-day traditional performance testing that we are doing for any application. So as majority of the applications, right, if you take, as most of them are Java, still sitting on monolithic uh, and legacy connected to legacy systems, and they are continuously emerging. We'll try to understand from where these performance bottlenecks are happening, where are these degradations, how to identify them, what is the corrective action that you have to take, and how to identify the problems and how to correlate them, okay, to derive some conclusion on what went wrong. So today we will talk about the problems, especially we have been discussing and hearing about a lot of not new concepts, some strong concepts, which are like heap dump analysis, thread dump analysis, where we are primarily dealing with out of memory errors, heap dump, memory leaks, and coming to the resource contention, deadlocks, all of that, right? We need to understand when to do what. For example, uh, for all the memory related issues, you need to take heap dumps, right? For all the resource contention and deadlocks, you need to take thread dumps. Taking both of them may not be sufficient, but you have to go ahead and you also need to add something like GC log. So when does GC log comes into picture? And I'll also tell you what is the role of profiling tools, okay? And what they actually reveal, how monitoring tools and profiling tools are different, and how you can make use of the in-house profiling tools that are available from Java JDK 8 directly. And as many of you have some questions, right? Let's say, is it completely theoretical or practical, all of that. So today I'll drive you through some of the use cases. I'll show you the lab setup that we have, and there are some other code snippets which can simulate the memory leak, out of memory error, excessive GC activity, all of that. And don't worry, we have a dedicated lab setup with some Java application that is already deployed in Apache Tomcat 9.x, which is connected to MySQL database server. So we'll find out how we have to identify the problems when a performance testing is happening. We also have some couple of scripts that are readily available, which were developed in LoadRunner. When I run it, I'll tell you how to look at different activities. Okay. Now, when I'm talking about some of the performance problems, right? If we start talking about, or if I ask as a trainer, or if an interview panelist, someone is asking you, what are the bottlenecks you identified in the last project? Okay. So, what is the first bottleneck that comes into your mind? So, let's say you're working with some application, right? What is a common bottleneck that comes into your mind?
Memory leak.
Memory leak, out of memory error. So now what I'm saying, performance problems, when you do performance testing, right? The problems are unpredictable. It's inevitable that web application problems are going to happen. You don't know from where. It can be from client side or server side, or from the network side, or from the infra side, or from the component side, or from the operating system side, or it could be from the environment and the configuration side. Okay. One API call can completely bring down the entire performance of your application down. It can crash and destroy the databases in production. Doesn't matter with what load you're testing, what load it is having, but one single API call or a simple spaghetti code, or a simple SQL query, anything can destroy the entire application and system, and it can break everything. So when you talk about performance problems, right, especially when it comes to load testing, we have something like monitoring based on the evidence, based on the metrics. We are saying this is the problem that has happened. But you have to remember these performance degradations can come from anywhere. Sometimes, as a performance engineer, you need to know from where to look actually. So, I have decided to give you some of the key bottlenecks or most common performance problems that you will encounter, regardless of any years of experience you have. And when you do performance testing, when you perform any type of testing, be it load testing or spike testing, stress testing, what you can see is you see high response times, right? When I say high response times, even if it is with small load, very less load, you see less utilizations, but you see high response times. That is because of spaghetti code. When I say spaghetti code, right, it is poorly written code. If you have heard about something like 80-20 rule, so 20% of the inefficient code can create 80% of the performance bottlenecks. Okay. So when your code is not up to the mark, or when the code is not as per the design, or it is not effective or efficient, right, it can lead to multiple web application issues. For example, when I say spaghetti code, right, using inefficient algorithms, bad application design, you may see memory leaks or application deadlocks. And even if you go with some of the applications like Bank of America or other wealth management applications, insurance applications, they're still working with legacy applications, which means that you still have older versions of software which are integrated legacy systems can also bring the performance down. So you have to ensure that your code is working with the latest versions of the tech stack, because these particular legacy systems, right, when you work with a sensitive application like banking and financial systems, what happens is you will not have access to see the source code. When you can't touch the source code, you may have 70-80% of the bottlenecks from there, but you will not be able to do any kind of profiling, right? So I'll show you how to do profiling. So the first point is you are all the problems mainly are because from poorly written code where the code is inefficient. You cannot say the code is bad without doing code profiling. So when I say code profiling, right, when you do code profiling, you cannot do it in parallel with performance testing. When a load test is running, you cannot do profiling activity in parallel with the test that is running because it is very memory intensive. So when you're doing a code profiling, right, you're identifying the transaction with high response times. You go to that particular activity, you connect your profiling tool with application server with the JVM where your application code is deployed, and you identify that use case, you manually do it, and you identify which method, which call, which function, which line of the code is actually consuming all your resources. For example, there could be one function or two functions called together can consume 80% of your application server CPU. So to understand that, to identify that, what you have to do is you have to profile that particular transaction, and you have to see which line, which method, which function is actually creating this performance degradation, right? So that is the first bottleneck. So for poorly written code, what you have to do is you have to do code profiling. And I'll show you. It is not theoretical. We'll take a deep dive and I'll give you more insights on that. And coming to the databases, right? Most of the problems, I'm giving you a very high level common performance problems. When I'm talking about the databases, right? So if you take the complete chain of the performance testing lifecycle and performance engineering lifecycle, You have so many components involved that are talking to each other. Let's say you are sending a request from client to the server. It goes to the router, then it goes to the firewall. Firewall has to authenticate it, then it has to go to some load balancer. Load balancer, depending upon the load balancing algorithm that is it has to evenly distribute the load. Then it has to go to the web server, database, application server, and database server. And there are too many components involved in that again. You have CDN, DNS, proxy servers. If you have separate messaging queues, you have to use Kafka. If your application is Dockerized and containerized, you have to see the instances of Docker and Kubernetes. And if some of the services are directly from the cloud, you may see multiple instances of the cloud. When all these things are integrated and synchronized, they talk to each other, and any component from here can have a performance degradation. So if you see this entire chain, uh, earlier in monolithic architectures, right, people used to say that 20% of the bottlenecks happen from the web server, 25 to 30% of the bottlenecks happen from application layers. Okay. And the remaining 50% of the bottlenecks, they happen from the database layer. So database is that important. When you have your database unoptimized, okay, if you don't know what's happening inside your database, you're doing a performance testing, you have one database where your multiple applications are pointed to. If you don't have, even if it is a dedicated performance testing environment where you're doing all the testing activities, if you don't have access to the database, if you can't see at least what's happening inside my database, you'll not be able to understand where is the performance degrading. Okay, based on assumptions, I know that my SQL server is down. My SQL server is having very high response times. I need to identify. I need to identify there are uh, some HTTP requests on the web server, or there are some methods invoked on the application server. There are SQL queries and stored procedures that are invoked on the database server. So when you send a request, right, any HTTP request on the web server, or any method that is invoked on the application layer, or any SQL query or any stored procedure that is running on the database server can be the reason for high CPU utilization or high memory utilization or high response times, all of that. So when I'm talking about the databases, right, you need to know what's happening inside your database. For that, you cannot say that, sir, people are not giving me access to the database. You need to make the teams to understand the importance of having access to the database, so that as a performance engineer, you will be able to identify what went wrong, why it went wrong. At least you will get initial insights on that, right? So here, an optimized database will give you the highest levels of security and performance. If your database is not optimized, it can bring and it can destroy the entire production application. So one classic example is missing indexes. Missing index can completely slow down the performance as a SQL query, and it can bring the entire website down. So that is one thing. As we are talking at a very high level, that is one case. So to do all of that, what we do is we take multiple AWR reports, ADDM reports, and ASH reports to understand what's happening in the application. So when I am talking about other performance problem, right, these are some common performance issues. What data you're using? I told you yesterday, there is a lot of gap between the performance testing environment and production environment, because what are all the testing activities that you're doing today? You're not doing it on the mirror image of what you have in production. It's not the exact replica. Let's say if your production application server is having 4 databases or 2 databases with 1 TB SSD and 128 GB RAM, it is capable of handling some 10,000 users. Now, if you have to test only with 1,000 users and tell what's happening inside your application from a performance point. So it is not directly that it is one tenth size of what you have in prod. Okay, when you're doing performance testing, like I said, when you understand the complete chain of all the internal, external, third-party components, third-party services, API gateways, proxy servers, reverse proxy servers. If you have multiple components in a distributed environment, when you're doing a performance environment from a scratch, what you have to do is you have to ensure that at least at least one instance of every component of what you have in production must be also available in performance testing environment. You have you have two load balancers, make it one in performance testing environment. You have different caching algorithms that are set at different server levels in a cluster database, in a server farm. You have to ensure that at least one database with all the production settings of what you have in production should be also be there in performance testing environment. That is how you are simulating the activity and you are publishing the results saying that this is the SLA of what we have tested. Okay, when I say data, right, data systems nowadays everything is data. You give a prompt, you get lots of data from an AI tool. You send a query, you get millions of records from a specific query. So when I'm talking about data, right, all the systems nowadays is all about data. So data systems, application systems that are dealing with data, they will tend to degrade over time. Okay. So you don't know what amount of data you're retrieving from a server. What is actually throughput? For a given request, you're getting some response, right? You send a request. In a request, what do you have? What do you have in a HTTP request? HTTP header, HTTP request body. You're entering the user ID password and clicking on login. It is taking the user ID and password. In the request, you will have a HTTP request header. Then you will have a HTTP body, HTTP request body. In the HTTP request body, you're going to have that HTTP request message of what you're sending and what you're asking from a server to give. When these details are sent, in the HTTP response, what you're getting? Again, it is a data. You're getting HTTP response header along with HTTP response body. HTTP response body is having the message, response body is having a response message of what message you are getting in as a form of acknowledgement for the request that you asked. And in addition to HTTP response header, HTTP response body, you will also get HTTP response code, which is 200. It is saying okay. So when you're doing workload modeling, what will happen is when you identify the transactions, right? This is a heavy transaction. This is a very weighted transaction. When you're having a TPS, what you primarily focus is you're trying to understand the size of the message that you have in a HTTP request body. You may have 5 MB, you may have 50 MB, you may have 100 MB. If you're uploading a file of 100 MB every day, these systems will degrade. So what you have to do is when you're doing with huge amounts of data, you need to develop a plan to manage and monitor on how the data is growing on your application. Because if you don't do that, if you don't know how to create that exact data of what you have in production when you want to test it, you will have to see more performance issues. And here the problem is you are suspecting something else if you don't have the evidence-based what diagnosis. You see a problem, you are seeing high response times, your throughput is flat or your throughput is dropping, your hits per second is dropping. You cannot blame something else, and if you do that way, you're wasting time and you're going in a wrong direction, which can give you other bottlenecks, which are not really true. You're working on a uh, different different place where there is no necessity. Okay, So when you talk about the data, you need to find out who is accountable for this data growth, what your business is doing. From there you have to research and find out the storage for your data needs. What amount of data? Let's say what amount of data when I say what amount of resources are required on the database from the hard disk point, from the RAM point, from the operating system point, how the database has to be, how should I look at all the options from databases to caching, right? So because I need to define more sophisticated layer storage solutions. If my storage on my databases are undersized, I have to see different problems. And coming to the other problem, right? When I say traffic spikes, um, even if you start a YouTube channel, you are doing something on it, you are publishing content, or you are doing something on Instagram. General expectation of any business is to have an increased traffic. You think that increased, generally, we think that increased traffic is a very good thing. But when we experience major traffic spikes after a marketing promotion, your business and your application has to be ready to deal with the traffic, okay, with the uh, acceptable response times, acceptable resource utilizations. Okay, so for that, I'll tell you what you have to do in production traffic analysis. And like I said in the yesterday's demo, you have workload modeling. Three things are very, very important for performance engineering. One is workload modeling. If your workload modeling is wrong, okay, when I say workload modeling, right, you have poor load distribution. If your workload distribution across your transactions is not accurate, is not uh, as per your production application, you will get different metrics. You're doing workload modeling on a low prioritized functionality, and you see high response time on that. And now you have to skip the other priority business transactions here. So when you go to the production application, you need to understand how these end users are making use of this application, right? You need to understand how the end users are making use of this application. What is the rate at which they're using? What is the concurrency? What is the peak hours, off peak hours? So if you don't understand this, and if you're doing a poor load distribution, everything will go wrong. Poor load distribution can give you complete slow response times by incorrectly assigning users to new transactions, and you have to wantedly bring down some of the servers instead of other components. So if too many people are on the same server, right, you obviously know that we are going to experience problems, and if the overall system is under capacity, you'll have to see timeout errors, you have to see failed transactions, you have to see high error rate, and you have to see application servers and database servers crashing, right? And other thing is, uh, whenever you do performance testing, most of the COE teams and other teams that I worked, right, people never try to understand what are all the configuration settings that you are having inside your application. It's not that always your fault. Uh, it is that you need to talk to people. You need to talk directly to the customer to find out what are all the default configurations in the environment. I'll give you one example, okay? For a database, when there is a situation where I have to test an application with 4 lakh or 5 lakh unique records. Okay, this was not added in the initial days of my career when I'm 3 years, 4 years experienced guy. I never identified that the data is unique. After identifying that, I didn't add anything for a timeline for creating this data. So creating 4, 5 lakhs or 16 lakhs unique records, for example, bank account numbers or SSN numbers or credit card numbers is a very huge task. It's not like now you have many tools available where you can purchase the license and you can generate the data in seconds now. But it's not working that way. So you have to create Excel sheets, you have to drag and drop, or you have to run some SQL scripts. When that data is created, right, there is a data access path of the database. Okay. So you have some 5 lakh SSN numbers. When the data is created, some people from the test data team can come back, they come back and tell that this data has to be uploaded and it has to be tested. So how do you make sure that this data is working? You go to the application, you search with SSN, you take one value out of the records, 5 lakh records that are created, some two or three, you manually search it and you see that record. So once you use it, it will not, so you didn't use it in the main use case, you are using it for search, but you are using it for doing some order. Once it is used, you cannot use it anywhere. So when the data is existing, right, you need to give a confirmation to the database administrator to upload this data. So when you have to upload the data, most of the service-based companies, right, each of the team is separated. I mean, they're centralized. So if you go and talk to the DBA, DBA is going to do that. But if you're running a one-man show, there is a situation where you have to upload all this data on the database. For that, if you don't have 20% of the concepts of the database, if you don't know what is data access path, if you don't know where your application is going, to which table it is talking to, if you don't know the data access path, you cannot go and upload the data. For that, you need to go with data access path. That is not a default configuration. That is another configuration. So you have to know that data access path. You have to upload it, and you have to do all of the different activities. So systems must be properly tuned. If you go with the default configurations, it is easy to make the all the internal, external, third party new components up and running, but these are all not always appropriate, especially in performance testing environments. Okay. And I know that it is very hard to get all the configuration lists to create a performance model. When you say performance model, right, you are creating a performance testing environment which is same as prod. It is a mirror image and replica of prod. Every setting has to be checked. Example, uh, now I'll show you. Wait. Okay. Let's. Give me a minute, please.
So that whatever we are discussing now, those all comes under the spaghetti code, which is nothing but something related to code issue in Java. These are also some points that we need to know. Is that right?
Right. I mean,
Okay,
these
okay.
are some of the common performance problems that you see. We'll go to Java now. Okay, it's not that common. You see these problems in many of the Java-based applications. Okay, now uh, you're able to see my screen, the new server.
Yeah.
Okay, allow me a minute. So okay, not this one. Okay, we'll complete this and I'll tell you. Okay, and coming to the other problem, right? I told you the existence of DNS firewall and network, right? So when you say, I mean, if you see the DNS firewall and network, if you don't take all these components into consideration, you will experience the hidden bottlenecks. Okay. When I say hidden bottlenecks, if you see the WhatsApp outage or if you see the Insta outage, it's not that you have too much of load, too much of traffic on this WhatsApp. The very recent outages, if you go back and try to understand, one of the major WhatsApp outage that happened is because of DNS. Okay, when you get time, you read it. And when I say firewall, right, what is that firewall command? wf.msc Windows firewall. So if you see here, right, there are some inbound rules and outbound rules. If you see some of the rules here that are set, if you can create, you can also monitor your firewall to understand uh, how these things are working. Let's say I'm using Zoom. People are connecting from different geographical locations. You can also see somewhere a zoom.exe that is currently running. When it is running, right, you can see the inbound rule and the protocol that it is using and the local port that is running and the remote port. Okay. So now, if you have to create an inbound rule or outbound rule, and if you don't give permissions, right, you are creating a database, you are my team. If I create a database and I want to give access to the database, I have to set up a new rule. I have to set up a new rule. I have to define a new port. And when I give a port, I have to select the protocol. Or if I have a custom port, I have to select that and I have to allow someone or 5 to 6 people who are part of my team to access my database. Without doing that, you are getting some error in the date in the load runner when you record a script. Your manually it is working. In the load runner when you're doing it right, you get a problem. You never know that there is something like this that is set on the firewall. There is an inbound rule, outbound rule, and most importantly, if you set a rule right, when you set a rule, if I give a port 8080, if I give this port and if I say block this connection, right, I can do that. If your connection is not secure, it will block you. So you think that it is a problem from the application and you say that you directly report it to the QA team and they have to raise it from there to the development team and they work on it. It is still working. Even if the developer is not able to understand this is a problem from the other side, it can be from anywhere, okay? Again, from performance engineering aspects. From other side, he'll change the code and he'll give you a different functionality. Initially, the response time was around 300 milliseconds. Now it went up to 513 milliseconds, where the response time has been increased. When the developer is running that API or that particular source code in an isolated environment, which is an IDE, okay, the waiting time or execution time or whatever. So when I talk about DNS, firewall, and network connectivity, you can also see server latency. Most of the applications will have latency problems, right? When you don't have a monitoring tool in place, you have to understand what my application is doing, resource monitor. If I go here, you have to observe very clearly. TCP dump is it's a different story. If you go to the network, this is my process ID that I'm currently using. This is my application, zoom.exe with the process ID, send bytes and received bytes and total bytes. Okay. You can also see the network activity here. This is with the process with network activity and TCP connection. If you see here, this is a TCP protocol. 27, this is a process ID, local address, local port, remote address. And you see the packet loss is 0, right? You always have to see the packet loss as 0. If your packet loss is not 0, there is a problem with the network. And you have an application that is already running. From the latency point of view, you have 269 milliseconds. If it is not that, if you're seeing something in seconds, this is experiencing latency problems. It is not, it has nothing to do with the configurations. It has nothing to do with development, code, nothing. You are experiencing latency. There are many reasons for that, and that is a different part. So this is something I want to let you know. If you're not seeing packet loss as zero, if you're not seeing latency in milliseconds, and instead of that, if you're seeing it in seconds, you don't know. Okay. Now I'm also talking about one of the primary bottleneck, default configurations, right? When I say default configurations, this is my application. Okay. If I go here, if you go to command prompt, you know what is JPS command doing? What is JPS command doing? Or JPS-L doing? Any idea? Let's say that you are able to see my screen, right? The perf server i781. You guys are able to hear me?
Yeah.
All right. So this is my application that is deployed in my local host. Okay. Instead of this place, you can also give the host name. Okay. Now it is not opening. So this application is actually deployed in give me a minute. IQ, Apache Tomcat, inside bin. You can double click on startup bat, or if you do this thing right, it is going to start your web application server Apache Tomcat. Okay. So when you work with Apache Tomcat, this is where I deployed my application. Okay. Before this thing, I'll tell you one more thing. You're doing a performance testing. Okay. Your database is MySQL. When you go to MySQL database, if you click here with root user, you will go to MySQL database. You can look for different activities here. Now, inside the server status, your database is busy or your CPU on your database is so high. You are experiencing so many performance problems from the database. You have so many queries that are running. So much of DML activity that is happening. Now, my first thing that I would see is I would go to server status or I would go to dashboard. Can you see this thing? Do you know what is this thing? What is client connections? No idea? What is client connection? You're seeing, right? 151, what is it?
Could you repeat the question, please?
Sorry, I couldn't hear you. Can you please repeat that for me?
Yeah, sure. Can you repeat the question?
In MySQL, 151 client connections total that you're seeing here is the default maximum number of concurrent connections that are allowed to a database server. So there is a parameter inside MySQL database server where you are setting max connections equal to 151. Now tell me, what is a client connection mean? What do you understand by something called client connection?
Client meaning from our system to network or
Perfect.
so.
So a client connection is one active sessions that is connected to MySQL server, right?
Yeah.
So the client connection is one active session that is connected to MySQL database. For example, it can be one application thread. or one API request that is holding a database connection, or it could be one background job, or let's say this way, one admin logged into, it can be a root user, or it could be another super user who is actually the owner of MySQL client, MySQL database, or it could be one monitoring tool connection. So again, don't don't get confused. One connection is not equal to one user, but one API call can consume one connection. Now, again, the question is, why is this value set to 151? It's a simple MySQL server default value is 151. This MySQL server is designed to protect the server itself from overload, because each connection, each client connection that comes to the database will consume memory. When I say memory, right, inside memory, you will have a thread stack, you'll have buffers. We'll take a deep dive on that, don't worry. You have a CPU scheduling. When you get a client connection, right, it will tell what CPU has to do, what work it has to do, and what tasks it has to accomplish. And each connection will also consume logs, some of the internal structures of the server. Because if this is not set to 151, or if this is not set to one value, if you're giving unlimited connections to the MySQL database server, if unlimited connections are allowed, what will happen? Server will go out of RAM. Context switching. Please make a note of this point. I'll talk about this later. Context switching in CPU. You might have faced this question like in many interviews. Context switching, if you have unlimited number of connections that are set on a database, context switching on your database server would explode. DB server would become much more slower, and it will have different problems. Okay. Now, on a final understanding on the configuration part, now tell me what happens when 151 connections are reached. Any insights? Anyone want to answer this point?
It will not allow the new connection, so it will be blocked if they are active. If not active, then the old one, no, inactive.
We'll talk about the connection pool, connection leak later. Okay. But I'll tell you what. When it is reaching 151 connections max limit, new end users will start experiencing this problem. Okay, too many connections error. At this point, what will happen is your application, okay, reject new connections. Okay, too many connections error. Your applications will application requests fail. Your APIs will time out, and your system appears down even if your CPU is okay, memory is okay, because your connection pool has been exhausted. Now, I'll make you one last understanding on this part, because this is important. This level of understanding on every aspect, on every concept is very critical, because to say something, to define something, or to derive a final conclusion on a specific performance testing project, you need to tell what happened, why it happened, what are the symptoms, how did you fix that, and what is the root cause analysis you performed. Everything is evidence-based. You cannot simply say that this is happening because of this particular aspect. No, you cannot say that. Any performance conclusion is very expensive. Now, if I give you a real case example, your application has a connection pool size which is 50. Okay. Now, there are 3 app instances. Listen very carefully. You have a background job pool, which is, let's say, 10. You have 10 background job pools. And you have some monitoring tools, which are again 5. Now, how many connections you have? It is done, right? 50 multiplied by application pool multiplied by 3 app instances, which is 150. Then you have plus 10. Then you have plus 5. Total, you have 165 connections. Result is too many connections. So this is the configuration parameter that you need to understand. You have 151. I'm just seeing 14, 15 when I'm doing a load test. I don't want to worry about this thing. So common misunderstanding from a performance testing point of view, performance engineering point of view, very important. Increasing maximum number of connections on a MySQL database will not automatically improve performance. You cannot raise it blindly. If you do that, your memory usage will explode. The log contention on the database will increase. Query latency, you will have to see the worst numbers. And your DB completely, that becomes unstable. Okay. So I'll tell you what is the correct way to handle MySQL connections, connection pooling. How do you open DB connections per request? What is the formula for that? Or how do you size maximum connections based on RAM? All of that I'm going to tell you in the upcoming sessions. And if you have a question like when should I increase max connections, then you cannot blindly increase, but there is a question. When should you increase?
But connections are reused, right? Once the query execution is completed, the connection, it goes to connection pool. So again, when the request is coming, the connection will be used again. Is that right?
Okay. Actually, yes. So if your connections are waiting, not idle, okay, you can increase it. But you need to have sufficient RAM on your DB. And if your queries are already optimized, you can increase max connections because the pooling should be correctly configured. So you cannot increase it to 1,000 to hide the bad design or something, but you can increase it when your queries are optimized, when your database is having enough resources like RAM is available, your connections are waiting, not idle, and depending upon different parameters. Okay, this is one thing. Now, talking about this thing, this is one simple thing I want to explain you, but we'll go one by one. I'll also tell you how to watch performance reports and all. If you see this one, right, in the command prompt, the startup bat file, it has taken a lot of time to start my server. You cannot close it. Once you close it, right, it will not work. You can see a successful message startup.catalina.start.server startup in 35182 milliseconds. When you do it, you have to check. This way is what you have to check. See, when you get a login page, right, it doesn't mean that your application is working. Most of the assets of an application are being managed by the client side. So it's not coming from the server. So when you see some page like this, you need to log in. Okay, you logged into your application. Now, if you go to command prompt, right, JPS-L, do you see? How do you know the process ID of the application that is running on your application server? JPS will give you the process name. It's a bootstrap application. The Java application that I'm using now, IdentityIQ. JPS is a Java process. It is a command again, which has some process ID, which is already running. So if you want to give JPS-L, it is going to tell you the details of your application along with the process ID. You have seen it, right? Now, your application is deployed. If you want to go and make some changes on your application, 8080, you can go to server status. So if you have to see Tomcat users, because I forgot the username and all, if you have to see Tomcat users XML is there, right? Go there, open it, and see what user ID, password I. So you have to give the username and password here. Okay, must be changed. You have to give the username and password to go inside the server, and you can also increase the heap size and all of that. Now, these are all the sum of the common performance problems that you will experience. Okay, let me go there. So these are some of the problems that you will face, but when it comes to memory leaks and out of memory error, right? Can you tell me what is the difference between a memory leak and out of memory error? People mix these two terms all the time. I'll make it crystal clear with some example, and I'll create a mental model that you'll never forget, because we have a lab setup, we have some simulations, so that you will understand what's happening with your application.
Memory leak meaning we see the on APM tool, right? The memory keep on increasing. Like from normally it runs on 40-50%. It's keep on gradually increasing on load test or endurance test. Endurance test after a
Okay.
couple of hours, right? It goes up to 90, 95, 100. It touches. That's a memory leak.
So you mean to say that MS Paint is still available? So
Or when unused.
you know what does this mean? This is a memory heap graph. You know what does this mean?
A young generation happening on time.
No, don't go there. We will not complicate.
Okay.
So this is
Is
a
heap
sawtooth
memory
pattern.
graphs.
Hat memory graph.
Sawtooth pattern.
This is sawtooth pattern, okay? So what happens here? So whenever the objects are getting filled up with memory into your heap area, so your memory actually increases. This is the point where the GC will happen as expected, and it will delete all the unreferenced objects. It comes back to zero. This is the 0 point. Now again, the memory will gradually increase. This is the place where the GC will kick in, and it has to free up all the unreferenced objects. It has to reclaim the memory from the heap area, and it has to bring back, right? This is a sawtooth pattern. Instead of this thing, this is the general heap graph. Instead of this thing, if your memory utilization is something like this, I'm sorry, my throat is bad. So you have something like this, and somewhere it is going like this. This is what? Excessive memory consumption. First thing is some abnormal behavior with excessive memory consumption. Now, if it is this way, I'll tell you one line difference. Okay, I'll not confuse you initially, because anyway we'll talk more on the heap side in the upcoming sessions. So memory is still available, okay, but your application will forgot to release it. Your memory is available, but your application is not releasing the memory. That's the memory leak. What is out of memory
Or
error?
garbage collection.
No, we'll talk about the garbage collection. Memory leak, you have memory on your JVM or you have memory on your application server. Your application is not releasing the memory because GC is not working as expected. GC is trying to delete the unreferenced objects and reclaim the memory. GC is explicitly happening. Every time GC is happening, the normal behavior, the GC is now run. When it is triggered, right? It is running. GC cycle 1 has been initiated. It has to pick 100 unreferenced objects. It did that. The memory has been reclaimed. And the objects again coming into the heap, the transactions are happening. Again, at some point, as soon as the young generation or old generation is full, the type of GC would differ. Minor, major GC will trigger. And it has to delete all the 100 objects again. And it has to reclaim. It has to free up the memory. Now, GC is continuously happening. It is not able to delete the unreferenced objects. Now you see continuous growth. So in the memory leak, you have memory available, but your application is not releasing that. It could be because of the code problem. But out of memory is a different case. Out of memory, you have no memory left to allocate. JVM is dead. You have no memory. Okay. Now, if I have to give you more insights on what memory leak, memory is occupied, what it really means. Okay, memory leak happens when objects are no longer needed, but they are still referenced. GC is not doing its job as expected. So here, like I said, garbage collector is not able to free them. So when with what symptoms you have to identify? You see a gradual increase in heap usage. For example, if you see, there are some examples that I can explain here. There are some examples I'll explain. Allow me a minute. I don't know why I opened so many things. So, yeah. So this is memory leak example. Okay. I have a code snippet that is available. I'll share it later when you join the sessions and all. Now, if you see this, this is a simple code snippet which will simulate a memory leak example. Okay. Now, if you see, that's not a big deal. You have to go to the JProfiler. I have configured my JProfiler with the Eclipse IDE, which is a JProfiler is nothing but a profiling tool. So if you see here, right, in the session, you can go to IDE integrations. You can select the integration version. Mine is Eclipse 4.x above. So I did that, and if I click on OK, right, it will tell that it is already integrated or something because I did that. So you have to integrate your source code. You have to integrate your JProfiler with Eclipse IDE where your available source code is there. And from there, you can profile it. You can profile as Java application. As soon as you do this thing, it opens a JProfiler and it will give you what's happening inside a JProfiler. Okay. Now, if I don't worry about settings, I'll click on OK here. Now, you have to look at the memory. Your free size is 1.28. For more insights, again, this thing should work. Performance. Your CPU is what? Why your CPU is clocking 90%? Your explicit GC is happening. When GC is explicitly happening, it is trying to free up the memory, but it is not able to. The memory, the blue one, right, that you are currently seeing is the memory that is getting occupied. GC, every spike that you see here is the GC trying to delete the unreferenced objects and it is trying to reclaim the memory. But it is failing, okay? So if you see here, memory is 13.3. Now if you see 13.4, you're able to see, I am hovering my mouse, 13.5, 13.6. At some point, what it will do, all the available memory will get exhausted. If it is above 14 now, you will not be able to hear anything from my side because it will kill all the other resources. Now I have to close this because at some point, it will keep on increasing and it will not leave any available space for me to use the other applications. So eventually the application server has to fail. Okay, now I'm closing it. This is the memory leak example. You understood? Now I'll tell you the common this thing. Even out of memory error also same thing. If you go to yes, you're asking something. I'm sorry, someone is asking something. Okay.
Yeah. Unrefreshed objects, you mean not objects.
We'll take it in the last. We'll take it in the last. I'll explain you. Now, out of memory example also you have similarly you have something that there is a code snippet that is available where you can configure it to JProfiler. And when you do that, right, it will tell you what exception you will get. Java.lang. Out of memory is the biggest exception. And this exception can come from anywhere. It can come from young generation. When I say young generation, it could be from Eden space, multiple survivor spaces, survivor 0, survivor 1, or it could be from where? It can be from the old generation. I'm closing it because my services, my resources are not sufficient. So I'm also closing this part. Now, if you see this one, now I'll make you understand one point. You can also do the profiling other way. I logged into my application server here. I logged into my application server. My application server is up and running. You can also do the same thing. If you give the local host here, right, it will work here. Local host, it is going to work because this is a local host where it could identify itself as local host. Now I came out of this server. Now if I have to open it, I cannot give local host here because i781 is a different server, right? So what I'm doing, you can also access this application from here. Again, to open this application from your end, like this, if you have to access my server, I have to set an inbound rule or outbound rule for you to access this application. That is how the access is provided to any of the users to make use of that application, especially when you're testing. So anything, I mean, in a controlled, isolated environment, if you have to test it, I have to add some inbound, outbound rules. I have to give a separate port. I have to accept you only if your connection is secure, all of that. Now, I just showed you how this thing is working on outside the server machine. Localhost is fine here. If you have to profile something from the Java level, I'll show you two different activities now. You go to program files. Then you go to Java, JDK. Inside that, you have JVisual VM.
You are not able to see screen.
Sorry? You're not able to see my screen? Can anybody confirm?
Yeah, now we are able to see.
Able to see, no problem.
Okay, all right. Now you're seeing something here. What is it? I highlighted that for you.
Tomcat PID.
Tomcat PID. That is the same thing that you're seeing, right? JPS-L. You're typing something like JPS-L. What is this? Bootstrap 11696. Is the same thing? Okay, inside this one, if you go here, you may have a question, how do I take a heap dump on out of memory? When it is completely out of memory error, how do I take a heap dump? You cannot take it. But you can do one thing. You can simply right click on it. You can enable heap dump on OOME. As soon as out of memory error is happening, it will automatically capture a heap dump for you. You can enable it directly from the JVisual VM. You can disable it. Now, if you double click on it, it is going to show you this thing, okay? The heap pattern, the threads, the sampler, the profiler, and this is where Visual GC is a plugin, okay? You have to go to tools, you have to go to plugins. Inside plugins, you have a Visual GC plugin. I already installed, okay? I already installed. So this particular plugin, it is going to give you a high level diagrammatic representation of what's happening inside your JVM. So what happened inside your JVM? What are you seeing here?
Hidden space is full. Full means
JVM metrics, you can see the breakdown of your heap, right? This is young generation. Young generation is a combination of Eden, survivor spaces, multiple survivor spaces, S0 and S1. You have old generation. This is a meta space, which is a non-heap memory. You can see the GC time, how many times the GC happened. The 19 collections happened so far. Eden space, you can see survivor space. Nothing is bad. Everything is going good, right? Now, I will run one test for you to make you understand. You will get, I'll connect to another server, okay? Not from here.
But in the real time example, how many times GC should happen? I mean, now it is showing 19 seconds, so milliseconds or something.
It will happen in lakhs. If it is a high traffic application, thousands and lakhs is what the number you will see. The number of GC cycles you're saying?
Cycles, yes.
The number of GC cycles, you can't even count that number. You'll have that many things when you're dealing with high traffic. Okay? Now I'm connecting to one specific server, okay? I'll show you how heap memory will work. We also have, if you see this one, app server i76, I have created a script. I have created a scenario. I'm just resetting that. If you are, I'm starting this start scenario. Okay. I have two scripts, okay, with some transactions. If you don't start your application server, if your application server is not up and running, all the transactions would fail. Connection refused, something. You cannot talk about website user giving user ID and password. First preliminary check is you have to ensure that my application server is up and running. Now you have past transactions. Your application server is running now. If you go to application server now, do you see this change here? Because transactions are happening. You can see till now the heap memory is flat. Can you see my heap memory now? Because I started my test. Are you able to see my screen? Are you seeing the sawtooth pattern?
Yes.
The test is running. Now you can also see one thing. Earlier it is not showing anything. If you go to the server status, if you go to the client connections now, CPU load is 23%. You have 12 connections here. You have selects has been increased. If you go to the dashboard, You can see the traffic increasing now. The incoming network traffic increased just because you initiated the test. You are putting some load on the application server now. When a request is sent, it is doing a lot of activity on the application server where it is working with so many methods and other functions. Methods are invoked, objects are created. Now, if you see here, you can also see the outgoing traffic. Now you can see inserts are 32 per second, selects are 393 per second. This is all happening just because your application is being exercised with many number of users now. You got it? Now the client connections you can also see even the performance reports. If you see the applications high cost SQL statements with errors or warnings, there are two SQL queries which are executed and there are some warnings, no errors. There is one specific SQL query which is giving one error and one warning. These are not errors. You can also go to statement analysis. When you see statement analysis, you can clearly see these are all the list of SQL queries that are currently part of your low test execution. You can see the total count of the SQL queries that are executed, the total time that is taking, max time, average time, rows sent, all of that. Most important thing here is the server logs. Even if you want to start, you can directly click on stop server to completely stop your database server. And you can also go with users and privileges where you can add multiple users here as a root user and you can give privileges. Because I am the owner, for example, I am a DBA. In case of my absence, I need someone from the performance team to look at all the different problems, or I need a backup who can fix immediately when there is a problem, if you have to go ahead with some of the performance testing needs. Now, if you see, these are all the different parameters, which you will not see when your database is, when your application server is not really working. Not really having traffic. Now here you can click. Now if you clearly see here, right, you can forcefully perform a GC. You can see this pattern if you are continuously clicking on perform GC, right? You are forcefully trying to perform the GC where you are making the memory flat. So the only disadvantage of GC is, right, every time the GC is running, it has to use more computational power. Remember that every time GC is running, it is more CPU intensive. Those are all called, there is a concept like daemon threads and non-daemon threads. There are some threads which are being managed by the operating system, which run in the background. They're nothing but GC threads. If your GC is explicitly running, if your GC is continuously running, can I tell you one assumption? You have less number of GC threads that are defined on the application server JVM. Okay. So if you see here, these are all things that you can do. Not only that, I have installed JProfiler. If you go to JProfiler now, what you can do is, don't do this in real time, okay? You cannot add profiling to your load test in parallel. Everything will crash, nothing will work. If I'm clicking on attach to a running JVM, it is directly showing you the process ID. You can directly attach. You can directly attach here. If not that, if it is a new session, if you want to connect a new server integration, if your application server is different from Apache Tomcat, if you're using any other application other than Tomcat or IBM WebSphere or something, you can directly connect to JBoss, IBM WebSphere, WebLogic, Wildfly, all of that, and you can do it. At this point of time, what I can do is I can quickly attach to this thing. Now, if you click on heap dump, right, it will immediately take the heap dump. Now, if you connect to this particular thing, I am not distorted by short-term methods. All features, but again, it is a resource intensive. Make sure that you're having sufficient resources to do all these activities. Okay. It will take some time. Now, before I close the session, I also would like to talk about some of the case studies. When I'm talking about case studies, right? If you are experiencing heaped out of memory errors and memory leaks, right? You take a GC log. You also identified that too much of GC is happening, but you got to know that the rate at which that you are expecting the percentage objects that has to be reclaimed to free up the memory by GC is not happening. So when you take a heap dump, when you take a thread dump, you have something like excessive garbage collection. Okay. When I say, sorry, not excessive garbage collection, excessive object creation. So this is one of the important bottleneck, which we also call it as GC pressure. When I say GC pressure, right? The problem is it's going to create with less number of load. It is creating too many short-lived objects. When you have too many short-lived objects, there are more number of times the GC has to happen. The more number of times the GC is happening, the more number of stop the hold events has to happen. And you will obviously see latency spikes. This is happening because of bad code, spaghetti code. This is one of the main important bottleneck. If you ask me, how do I identify that? You have to take a GC log. Inside GC log, can you go on mute, please? I'm sorry for that. When I say excessive object creation GC pressure, you have to take a GC log. Inside GC log, you have something called object statistics section, object stats. Inside that, you have object creation rate. Based on the object creation rate, you will get to know whether you have too much of object creations, you have unnecessary objects, duplicate objects, you have too many objects that are getting created. All of that you will get to know. So if you want to identify that, you have to work with profiling tools. You have to take the GC logs. You have to find out the object, the rate at which the memory is getting filled, because the heap memory fills very fast. As soon as the heap memory is getting filled with new objects, right? The GC has to run. When the GC has to run, it has to give GC passes. When you have explicit GC running, when you have so many stop the hold events, you will have high response time. As a side effect, you will also have high CPU utilization on the application server. Okay, so from that you're going to have memory leaks, because memory leaks objects will be still referenced. No GC algorithm or no GC, minor GC, major GC cannot clean them. For that, you have to find out, you have to do code profiling. You have to see if some static collections are holding references forever, or old generation is continuously filling up. What is the rate at which full GC is happening? Why this out of memory is happening? All these things. For this thing, I would explain you on this thing. Application randomly freezes for 10 to 30 seconds. Any answers on this point?
Which means GC is happening frequently.
APIs, when you do it with less load, APIs are responding in milliseconds normally. But what's happening is suddenly all requests are freezing for 10 to 30 seconds. But CPU is okay. 10 to 20 to 30% is CPU. You went to logs, there are no errors. It is only happening few times per hour. Now what you have to do here is you have to take a thread dump. When you take a thread dump, your observation is like I'm sorry. Your observation is like you will see whether all threads are waiting or blocked. Initially, you will find out for blocked, then which threads are waiting. Number two. Number three is which threads are continuously running. You may have a question why my threads are continuously running is a problem. The thread that is continuously running without getting terminated is the main reason for high CPU utilization. Okay. Like I said, you will enable GC logs, you will take heap dumps, all of that you will do. So these are all some of the use cases that you will identify, especially out of memory error, right? When I'm talking about out of memory error, again, you see the memory utilization happened here. This is the generic thing. There is a GC happened. You can see this drop. This is where the GC has reclaimed all the unreferenced objects and it has freed up some memory. Again, there should be some GC that should happen. You can see only memory point of view. You can see memory pool, what's happening in hidden space, what's happening in old gen, what's happening in metaspace. Survivor's metaspace. You can see everything. Individually inside a JProfiler, you can see the GC activity, the classes, and not only that, if you want to take multiple heap dumps, right, you can take with all the references, you can take multiple heap dumps here, and you can also take thread dumps. You can take multiple thread dumps here. You take a thread dump. Then again, if you want to take a thread dump, because thread dumps are taken very frequently within a very less amount of time. Now you take a thread dump here. It's almost more than 10 seconds. I'm taking another thread dump. Now you can compare. You will see what's happening. What changed. Okay, you will have to take multiple thread dumps, and you need to find out which thread is changing its status. If there is a specific thread that is getting that is specifically blocked, specifically waiting, continuously running, you have to take multiple thread dumps at the point where you see high response times and CPU utilizations. You have to take thread dumps and you have to go with the stats. So if you ask me how to know that, there are many common symptoms that you will get to know. Like your application it suddenly crashes or the application will restart. Even your application server is restarting. You're running a test for 3 hours or 1 hour. In between the test, in the 1 hour test duration, your application server has restarted for 3 to 4 times. For the time the application server has restarted, you will see failed transactions, right? Server not found, something like that. Because at the time the transactions are happening, the server has restarted and the server is down. So application will suddenly crash or it will restart. Your requests will start timing out or they'll fail randomly. You'll see very slow response times before a failure that is going to happen. You see high GC that is happening. The memory is not reclaimed. And the error that you see is java.lang. Out of memory error. It could be from metaspace, survivor space, heap space. Sometimes you'll also get the same thing on Java overhead limit exceeded. So these are all because if you have to understand why out of memory errors happen, it is because of insufficient JVM memory. I'll tell you one last example before I close my class. If your application is having very small heap, your heap memory is very small for the workload that you're testing, then your application will fail. Example, your application will read and store a 256 MB file in memory. Okay? Your application has to read a 256 MB file in memory. Now the JVM heap memory must be larger than 256 MB. If it is not, again, not 256 MB, 256 MB plus extra space for application objects, frameworks, and garbage collection activity that is involved. Okay, JVM areas, you cannot undersize or wrongly size one specific area. You have to rightly size all the young generation, Eden, survival spaces, tenured spaces, old generation, code cache, permanent generation, meta space, everything. Okay, so we'll talk about lot of other things going forward. That's all for today. Thank you very much for joining and thanks for your time. Thanks again.